Hey guys, today is the day 6 of the 28 days data science AI Gen AI challenge. It's me, Mahesh again. Having 14 years of experience in data as a data architect, data scientist, data trainer, and a lot of things around the data. So today I'm going to talk about sentiment analysis for the stock tweets. Okay, so I've created a presentation first, and then I've created a Google Colab link. So I'm going to show you the Google Colab too. But before I go there, I'll try to showcase all the things what I've done in the slides. Then I'll show you the code. Okay, so in this presentation, I'm going to technically extract the stock tweets data. I've already got a data for you, so that you don't have to take troubles in how to extract with the help of the Twitter and all. Nowadays it is a bit difficult to extract it because you would need a lot of credentials and all. So I've just done that difficult part. I've got the stock data for you in the CSV file. I will upload that too. Okay, we'll analyze that stock tweet data. We will put forward all the learnings what we have done in the last 5 days and try to do a good model and try to put forward what kind of models are going to get at the end. Okay, so let's start. So as I was sharing, so the stock data consists of all the tweets around the stocks. Okay, so it consists of tweet. It consists of the stock, the name of the stock, what kind of things are happening around it. Okay, so in the initial findings, what I have done is that I've done put forward whose stock is the most spoken stock in the Twitter. So I've got to know that it's Tesla in the given data set. Okay, it's a very popular stock in the market right now. Okay, so the thing what you have already known about it. So in the last 5 days, what I was doing is that whenever we get the data, we do one level of cleaning. Okay, there is no missing values in this data because it is already extracted and it's already clean. But we have to do the normal data processing, the text processing, which we know, like for example the stop words, the lemmatization, stemming, the tokenization. So we have to do those kind of stuff. The only extra thing what I have done is that I have used regex to remove the special characters and all. Okay, which you will be seeing the code too. Okay, so here what I have done is that I have put forward a sentiment with the help of a library. Understand that because in the given text, in given data what I have, it consists of only the tweets and the stock of the name of the stock, right? It doesn't have sentiment right now. So I've used a library for that instantly, but that is just a base sentiment for me. Okay, going ahead, I'm going to use a model to also predict a sentiment. This model can be a go-to model for in the future for you to use and take it over from there. Okay, so as you know, so basically once the pre-processing is done, so I have put forward those data in the TF-IDF. So the most important words are going to get a higher score, and the less important words are going to get a lower score kind of thing. Okay, so I have introduced one more thing here, is the train test split. I have not done the train test split in the last 5 days, but train test split is very important in machine learning kind of stuff, because if you have a very good model, but you don't know whether this model is going to work in the production data set or not. Hence, it is very important to divide the data into train and test, where you have some data for as a train and some data for a test, and you try to implement the model what you have got based on the train model on the test data, and try to see the scores of both the models. If the scores are around similar to each other, less than, like if the difference is less than 5%, then I will say that the given model is a good model. If it is not like that, then I will say it is an overfit model. If the scores of both train and test are bad, then I will say it is an underfit model. So I've done the train test split. If you still don't able to understand, please let me know. I can always put one more video to explain the context. So I have somewhere around 64,000 tweets in my training data set, 16,000 outer tweets in my test data sets. Okay, after that I have implemented my model. I have used a Naïve Bayes model. Okay, the reason behind using a Naïve Bayes model is that it does a very good job when it comes to NLP. Okay, so I have got 82% in my training data set, 78% in my testing data set. It means as I was sharing, because it is less than 5%, the difference is less than 5%. So I'll say that the given model what I have created is a good fit model. Okay, so you can go ahead and do a lot of other matrices. I have put forward the confusion matrix for you and the other given metrics like precision, recall score and all. Okay, in features perspective, you can go ahead, implement different kind of models. Can do feature engineering, you can do hyper tuning, and take the model to the next level. Okay, beyond simple machine learning models, you can, the next thing what we are going to learn is that we are going to implement deep learning models. So this should be the way to go. Okay, so you should go with a less and simpler model first, and then, as if your simpler model is not giving you the required score, then you can go to the next level of a deep learning model or a Gen AI kind of model, which we are going to do the next stuff. Okay, so this is what I have right now. Okay, so let me stop here. The Google Colab link and the code which I was talking about. So like all the last 5 days, so I have created different cells, and I have put forward a title for everything what I'm doing. So right now, the first thing what I've done is that I've put forward all the libraries which I'm going to use, and the stock data. So basically, if you want to load the stock data, you can load it from here. Okay, so which I'm going to give it in the link also. Then after that, I've done an EDA, try to understand what kind of tweets I have, and for which company I have the most tweets. So you can see I have TSLA is nothing but the script name is for Tesla. So I have the most of the tweets is for Tesla right now. Okay, then I have done a basic preprocessing, which I have told in the last 5 days sections also, right? So I've done the stop word, I have done the lemmatizing and stemming. I have also done one thing which I was sharing in the slide. I've removed the special characters, the hashtag, the symbols, the models and all. Okay, which is because it's not going to be helpful for me when I'm doing the sentiment. Okay. Then because I don't have any sentiments in the data set, when you are doing a modeling, you need to have some kind of fast data for that. So I'm going to use a library called TextBlob, which is going to give me a sentiment upfront, but this would be a base sentiment. Okay, so the model which I'm going to use later is going to also work to predict the sentiments for my data set in the future. Okay, so I've got the sentiments. So I've got 20% negative, 30% positive, and 50% of as a neutral. Then I've put forward a TF-IDF, as I've shared. The words which are going to be important is going to get a higher score. The words which are not going to be important would get a lower score. So I've put forward a max features of 5,000 as the maximum number of words or tokens it can contain. I've done a train test split. Please go and understand what is train test split. Okay, if you don't know what is train test split, you can put in the comment. I will happy to explain you the train test split. Okay, then I have implemented Naïve Bayes. Naïve Bayes model is a very good model for NLP kind of use cases, right? It gives the best scores. So I've implemented that. Then I have put forward the matrix for my model. So if you see, because I've divided the thing into training test, so I have got the scores for training test scores, like you see scores for both. So I've got 81% for the train, 17% for the test, right? Then I put forward all the other matrices, right? Then the conversion matrix. A very quick recap. So basically, when I was creating this code, so I actually didn't do all the text processing, and I was trying to see whether I'm going to get the score, good score or not. So I was getting a score somewhere around in the 70 range. So when I improved my data processing, my scores had improved. So very quickly understand that if you do a very good transformation on the data set, which is going to be helpful for the modeling to do a better model, your scores are going to improve for sure, right? So as a next thing, as I was sharing, right, you can go ahead if your baseline score are much higher than 80%. If your baseline score is in 90s, you can go ahead and implement the deep learning models, right, which you are going to see in the next days of the challenges. You can do a feature engineering, you can do hyperparameterization, and it is going to be helpful for that. If you don't know anything of this, please put it into a comment, and I'm happy to share the idea behind it. Okay, thank you.
If you have reached till here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement and enthusiasm make this journey even more exciting for me. If you found this valuable, drop a comment, share your insight and tag a friend who should join us. Let's keep learning, building and growing together in the AI and Gen AI space. Make sure to like, subscribe, and stay tuned for the next challenging stuff what is going to come tomorrow, because we have just started and it's going to get better and better as we go. Bye.